quarter. Okay. So now here's another problem that we're going to find the area under the graph of y equals 1 over x squared from x equals 1 to infinity. Again, I'm going to remind you of what this graph looks like. If you plug in 1, y equals 1 over 1 squared, well, you're going to get 1. Now, if I plug in 2, I'm going to get 1/4. Now, I will exaggerate this on my picture because if I don't, it's going to be a little, I'm going to put 1/4. That's really at the halfway point, right? But that's 1/4. If I plug in 3, I'm going to get 1/9. And if I plug in 4, I get 1/16. What if I plug in 2? Not 2, what, 1/2? I'm going to get 4. And this one has a vertical asymptote, that's the y-axis. It has a horizontal asymptote, that's the x-axis. And this one, the graph is approaching the x-axis a lot quicker than that other problem I just did. There is a portion of this graph on the other side, the y-axis. Just for fun, I'm going to put it in here. I don't really need it for this problem. If I plug in -1, well, if I square a negative, I get a positive. So I'm going to get +1. If I put in -2, when I square negative, I'll get positive. I get +1/4. If I put in -3, I'm going to get +1/9. And this one, it's symmetrical across the y-axis. But for this calculus problem, I would like to find the area from x equals 1 to infinity, and this is an improper integral. So this would be the integral from 1 to infinity of 1 over x squared dx. Now the problem with this is that infinity. I want a number right here. So I'm going to say, well, let b be a number, and I'll do the limit as b approaches infinity of the integral from 1 to b of 1 over x squared dx. So your job is to do this integral, plug in the b, plug in the 1, and then we'll take the limit as b approaches infinity. And I prefer to see this step. This is just me. Some of you don't necessarily need to see this step. The integral from 1 to b, that's x to the -2. So now to do the antiderivative, I'm going to add 1 to -2 and get -1. And then I'll divide by that -1, by that higher exponent. So I'll have x to the -1 over -1 from 1 to b. Now, the -1 that's in the denominator, that makes the whole expression negative. The -1 that's the exponent makes it 1 over x. So this would be the limit as b approaches infinity of -1 over x from 1 to b. And then that's the limit as b approaches infinity of -1 over b minus -1 over 1. Remember, you're subtracting the two values, and you got that negative that showed up when I did the antiderivative. So this will be the limit as b approaches infinity of negative 1 over b plus 1. What is this limit of negative 1 over b as b approaches infinity? That is 0. That's a problem from last semester. So this would be 0 plus 1, and the answer is 1. So I hope if this is the first time you see this, that you find this result kind of surprising. That here is a region that goes on forever, an infinite region with a finite area. The area of all of this is 1 square unit.